So in this video, we're going to talk about some of the differences between structures and classes, and we'll also talk about their similarities. So I've defined here two data structures. The first would be a structure that has an integer and then a character array, which could hold a C-style string. And we'll see eventually that there's no reason to actually do this, but I did this to illustrate that this structure is perfectly acceptable in a C program or a C++ program. So for the class, I used a string. We still have an integer. And then there's also a constructor, and we print out what that constructor is. So in my main function, I allocate two variables, one structure and one class. I initialize them. I have some pointers, and I'll use those later. And then I'll print out what the size of each is. So let me save that code. Let me compile it and run. So I have an error. And the first thing you see is for my class, the default is everything is private. So I need to make sure that I specify that my constructor is public. So I have some unused variables, but that's fine. And so you can see the struct is 20 bytes and the my class is 40 bytes. So one difference between the class and the struct is if we're going to try to access members. So let's do my struct A, and I believe that's an int. And then let's do the same thing for my class. And to line those up, we'll add a space. So let's compile. And you'll notice I'm getting an error, and that's because it's not my struct in my class. It's str and cls. Those are the variable names. And now I get an error on line 37 about something being private. And there, if we go up, notice we don't have a visibility modifier on A, so A is private by default. We didn't get that with the structure. Class members are private by default. Struct members are public by default. So there's one difference. Now you may think another difference would be, can we have a function in our structure? Well, let's write a function called dump, and let's do it in the class first just so that we can see what that looks like. And we'll implement that in the actual class this time. So it's going to be a void. We'll call it dump, and it's not going to take any parameters. Actually, let's have it take an integer parameter. We'll call that x, and the default will divide it. We'll say will be 16. And what this is going to do is it's going to print the members of the class. A is equal to A, and C is equal to C, and that's an inline. So let's do my class dump just to make sure that code works. And it doesn't look like it ever actually compiled that. Looks like, again, I've got to stop calling it my class. It's CLS. So let's compile it again. No errors that time. And when we run, okay, that's exactly what we want to have. So let's take that same exact function and let's put it in my structure. And I'll call it here. So we should get both outputs later. And it looks like we do, except that it should be my struct. But clearly this is the structures. We just printed my class in there. So if we can have functions, your next question might be, what about having a constructor? So here's our constructor for our class. Instead of my class, I'm going to call it my struct. Notice you don't put the struct in this case. The reason is inside of here, my struct is the structure, even though outside we have to refer to it as struct my struct. And we'll say that this is the my struct constructor. I don't think we can initialize this way. I'll give it a try. I've never actually done that, but I think that's going to be a problem. Yeah. We have this string and we're trying to assign it to be this array, and that just doesn't work. So we're going to need to write some code here to fix that. But we didn't get that for A. It's no problem to use the initializer for the structs that we can do that with. So what we're going to do is we're going to string copy into C. We're going to convert Y to a C style string. That's what that function does. And then the length is going to be the length of Y plus 1 because we need a null terminator in there. And that should do it. So let's compile. We got some warnings. And notice we get those constructors. Here's the sizes, and here we're accessing the members. So let's try to clean up some of our output here. And I'm just adding some notes in the output so we can see what's going on. So let's double check just to make sure we're happy with how that output all works. So I think I want to handle this a little bit differently. Instead of doing this in main, I'm going to do it in the dump function itself. So you may have wondered why those were char pointers. And it goes back to, if you will remember, actually, we've already seen that we can do our methods in our struct. So let's do it in the struct first, and then we'll copy that over. So I'm going to create a char pointer, and it's going to be equal to itself. So I'm going to set it equal to itself. And I want to make sure that we're not going to get in too much trouble there. Yeah. Okay, so this is a pointer to myself. So now I'm saying, now I'm going to treat that like a char. And then what I can do is in a for loop, and even though this is C++ code, I'm going to use printf just to get a little more control over the output. So I'm going to print 3 integers. And I'm actually going to make that an unsigned. I don't think that's going to cause any trouble, but just in case it did. So 3 integers, then a character in a field 5 characters wide, a hexadecimal 5 wide, and an integer 5 wide. And I'm going to print II. I'm going to print CII. And then actually for each of the last 5 values, I'm going to print dereferencing C plus II so that we see that as a character, and a hex, and an integer. And I'm going to test this just to make sure that it works the way I intend before I copy it. And what this is going to let us do, actually no, not C. I'm used to using C as the pointer in this particular example, but this should actually be pointer. Okay, so I think that looks a little better, or a lot better, I should say. So we have different signedness. It's not really a big problem. We shouldn't have an issue with that, but just in case. So notice what we're doing is this basically prints the information that's pointed in that structure byte by byte. So notice at byte 0 we have a 7, and that's the 7 that we initialized our structure with. Then we have some zeros because we just have some, that's actually 0007. We have hello, which is our string, and then we have a bunch of zeros. So what we could do if we wanted, well, I think 16 is a nice default. Let's go ahead and copy that function down here. So now they both will do it. Need to change that to an unsigned as well. Now, one thing you'll notice, the string in here is stored, the characters are there, this is the memory that's there. Here we have some other stuff where it seems like maybe we would expect that string to be. It doesn't look like those values are stored there. But instead of calling this with the default, why don't I call this with their sizes? So then this should print every byte that's part of that actual structure. And if we do that, notice there's some additional stuff here, but then eventually we do see somewhere in that class we've stored world, and then you can see there's some other data there. So what exactly you'll see on your code is going to differ depending on how your computer treats memory and so forth, but you should still see those characters somewhere in the actual structure as we print them out. And again, the way this function works is we're getting a character pointer to the start of memory where that's stored, and we're adding 1 each time moving through byte by byte, printing it out byte by byte. You can see here that structs and classes are actually very similar, and really the primary difference is just that in a struct, everything is by default public, and in a class, everything is by default private. But you can have functions and so forth in either.